Alright, so in this particular video, we have a crate of mass 85 kilograms. It is pushed up a rough surface, and the angle of the ramp is 20 degrees. And it says if the person applies a constant force of 500 newtons onto the crate that's parallel to the ramp, and if the crate moves at a constant speed, it wants to find A and B. A asks for the magnitude of the kinetic frictional force, and then B asks to find the coefficient mu k. Alright, so here's the diagram. Excuse me. The mass of the crate is given as 85 kilograms. The person pushing with a force of 500 newton, which is parallel to the surface of the ramp. And then the angle here is 20 degrees. And then here's mu k, which is unknown. So as usual, I like to remind you that for inclined surfaces, it's common to say that the surface of the ramp is the x-axis, just to make the math a little easier. And then perpendicular to that, watch how my cursor is tracing it. Perpendicular to the surface of the ramp is your y-axis, so your y-axis is no longer up and down the page. Okay, so here's my x-axis, which is the surface of the ramp, and then perpendicular to that is my y-axis. So if you understand that, then these components that are going to come up will make a lot of sense. If not, hopefully watch the first couple of videos I put out. Alright, so this is your f of g vector. So it's a good idea to draw out your forces before you start attacking these types of force problem. That's my weight, which is pointing down directly down the page. This is my f of g y. F of g y by definition is the component of f of g, which is mg, which is f of g times cosine theta. It's cosine because it is the adjacent relative to this angle. Okay, so the angle that's given in the in the diagram of 20 degrees. It is the same as this angle that's touching the f of g and f of g y. Alright, and then the next thing you should have drawn out is that, excuse me, it's the f of g x component, and f of g x in these types of problems will always point down slope, regardless of how you draw your ramp. Okay, so it always points down the ramp. Fgx by definition is mg sine theta, because referencing this angle between f of g and f of gy, f of gx is the opposite leg. Opposite in geometry would imply that it is sine of theta. Okay, and then the last thing we need to identify for our forces here, at least for now, is the kinetic frictional force. If you are pushing the crate up the ramp, the kinetic frictional force would point opposite of the motion. And in this case, opposite would imply that f of k points down the ramp. Alright, so it's important to draw your f of k correctly and draw it opposing the motion of the object or crate or box, whatever it is that you're pushing. In order to do part A, all we have to do is set up Newton's second law for the horizontal direction, aka up the ramp, because the ramp is now your x-axis. So here is net force in the x direction, which is equal to max. And then just expand sigma f x into forces or force components that exist in that particular direction. So here in this diagram, we have a force F in red here that is parallel to the ramp surface, which is pointing upslope. We have F of k pointing downslope. And in addition, we have F of gx also pointing downslope. So there's one vector pointing up. Excuse me. And there are two vectors pointing down. F of k points downslope, F of gx points downslope. So in my work, I have F minus F of gx minus F of k, because both F of gx and F of k are acting against the crate's motion. Okay. But the next thing we need to realize, and from the wording, is that it moves at a constant rate. Constant rate would imply the acceleration is 0. So here instead of ax, I substitute ax for 0. M times 0 will just be 0. I substitute out f of gx for mg sine theta, so therefore f minus mg sine theta minus fk equals to 0. To solve for f of k, because that's what part A is asking for, I would move f of k to the right side of the equal sign, which makes it a plus sign. So here I have f minus f of g sine theta, which is equal to f of k. Well, here I know f is 500. I know the mass is 85 kilograms. I know g here is 9.8. Once again, I want to plug in 9.8 because the negative sign has already been accounted for in my work. The theta is 20 degrees, because it's given in the problem in the diagram. So if we plug and chug, 500 newtons minus 85 times 9.8. Once again, this is positive 9.8 because the negative sign is already taken care of. Assign to 20. If you simplify this on your calculator, you should get a value of about 215.1 newtons. Okay, and it asks for magnitude. So I would just leave my answer as 215.1 newtons, or if it doesn't say magnitude, you can say 215.1 newtons downslope. All right. Part B asks us to find the coefficient of kinetic friction. So to find the coefficient of kinetic friction, we need the ratio between f of k and f of n. Well, we already found f of k from part A, which is 215.1 newtons. F of n, light work. Okay, so the green arrow that just came up on my screen, that is your f of n. F of n is the force exerted from the ramp onto the crate. So in this case, it equals to f of gy because there are only two arrows in the y direction. F of gy points down along the y direction, and keep in mind that the y direction is now slanted, okay? And then f of n is now pointing up along the y direction, so we can say the magnitude fn equals to the magnitude f of gy. So therefore, we can just do a quick substitution. F of k, I substitute in for 215.1 newtons from part A. F of n, I replace with f of gy. But then to the right of this, f of gy can be substituted for f of g cosine theta in the diagram here. Okay, so f of gy is equal to mg cosine because it's the adjacent leg of this hypotenuse, which is f of g. Well, we know what m is, we know what g is, we know what angle is. I can just plug in m as 85, g is 9.8, cosine at 20, and if you simplify in the calculator, you should get a value of about 0.27. And that's it. I hope that helps. Stay nerdy, don't be wired.